Hey YouTube, welcome back. Today we have this. We start a new series. We have a series to design a key value store. I guess this series will be like 12-ish, or maybe 12-ish video, something like that. Um, this in this series we will try to design a key value store, and basically, a key value store, also referred to as a key value database, is non-relational database. Each unique identifier is stored as a key with its associated value. This data pairing is known as a key value pair. In a key value pair, the sorry, in a key value pair, the key must be unique, and the value associated with the key can be accessed through the key, or can be accessed through the key. Keys can be plain text or hashed values for performance reasons, or a short key works better. What do keys look like? Let's just show what keys look like. Let's just add a new text. Make it smaller, please, Miro. Yeah. So basically, let's just make it really small. Yeah. So basically, a key will look like the plain text. It will be last, for example, last logged in at, and in as a hash key it will be like 235 DDEC 6 or 5. That will be key look like. The value in the key pair can be string, list, objects, or arrays. The value is usually treated as an object in the key value store, such as Amazon DynamoDB, for example. So basically, we have in the in the key value store, it will look something like. I guess I can create a templates. Yeah. Let's just see tables. Can we have table? Yeah, this one. Let's just take this one. Use it. Where is it? Yeah, thank you. So basically, let's just try to draw how the key will look like. No, can I delete too? How can I delete this one? Yeah, I guess from this one, delete, and yeah, from this one, delete, and yeah, let's say have this one. It will be, no, make it non-colored, and this one will be. So this will be the key, and this one, the key, and make it big. Oh, not that big. And this one will be the value. And for example, let's say I have a key here. It will be like 1, 4, 5. One. What's going on? It should work. Why? What's going on with the sensor? Okay. Okay, 1, 2, 2, 2, for example, and we have here. Okay, Miro, you have to work on your code. It doesn't look good. I don't like that. And I just. It should be when I change it once. It should be changing everyone. Let's say that we have these 3 keys, and we have. Let's make it bigger, and make it bigger so when we see it, make it here bigger also. And this is the keys, and each one of them is unique, and the value can be like again. Let me try to No, Miro, you were right. I was pretty wrong. I was wrong. Miro were right. So basically, let's say that we have John in the first one, or Jogan. I don't know. It's this one, and we just have Bob. Or in the last one will be Alexa, for example. So basically, we have this how the key value store will look like, and in this interview, we try to design this one to see how the key value store actually are and how to design one of them. And to be succeeded in any system design interview, we have to do specific things. One of these things is to follow our beloved framework, which is it consists of 4 steps. The first step is to understand the problem. Understand the problem. The second step is to propose high-level design. The third step is to take deep dive. And the first step is to wrap up. And I guess in this one, maybe we will just go directly to the deep dive. Like, understand the problem, and after that, start to go in the... Yeah. I guess in this one, we start understanding the problem, and maybe we just put the proposed level design and the deep dive in one step. And this also, you should be flexible. Sorry. So let's just try at the first one in understanding the problem. So let's just have a new text here and make it. I want to make it like. I want to understand the problem. So, understanding the problem, in my opinion, is the most important step. It's the most important thing in the system design interviews. If you get this right, everything will be right. If you get this wrong, the whole interview is ruined for you. So how can we understand this one? How can we solve this one? So basically, you have to ask questions. What type of questions? We want to know what and how and what. So the first what is functional, the second one is non-functional, and how the functional work or how the non-functional work. So let's just try to ask questions. So for example, the first question will be maybe we want to ask about the what type of key value store are we designing, and I will say that we're designing the pair. We know exactly what we're designing. We have this one exactly. So we want to go into the how the function work. What is the main functionality, or what we need the most. So let's just start with the first one, and I want to make this one is quite So I will say at the beginning, okay, so first, what is the size? What is the size of the key value? Like, if we have a key, and for each key has value, what each size can we expect? So maybe in this one, we expect the values of each key will not be big. It will be maybe 10 kilobyte maximum. So the values will not be that big. The second one I want to ask about the full database. Is the database scalable, or does the database have... Why, Miro? Don't do this for me. No, this one. Can oh, sorry. Can I just do it like that? Control A, and yeah. I don't know why Miro does this for me, but this is killing me, Miro. Just to please fix this. type of bugs. So the second question that we would like to ask, it's like, okay, we know that the value is under 10k. We want to know the full data. Is it data have a huge amount of key values, have a huge amount of objects and stuff, and the thing it will be is this is getting quite annoying, Miro. Is the data base does the database store a lot of does the database have the ability to store big data, for example? And I guess for this will be yes. So we expect to have tons of key values, tons of them. So the answer for this one, it will be yes. So let's just ask other question. Look, in this type of, in this step specifically, you want to ask from 5 to 8 questions or 5 to 10, depends on how complex the interview is. So maybe you want to ask about the so basically, do we expect that the system? Because here's the thing, that when we have data and database, and it should be should support a lot of amount of data, do we expect the scalability, like the scalability to be automatic, like automated? Does we expect automated scalability? And it will be here yes. Scalability, and for this it will be yes. So maybe you want to ask about a cap theorem question. And I will talk about what is the cap theorem in the next video. The cap theorem, it's we have the consistency, availability, and the partition tolerance. So we want to ask, do we prefer our application to be highly available, or highly available, or highly consistent? Prefer highly available or highly consistent. And we will say that we prefer our database to be highly available. So we want to say, okay, do we expect to have low latency? And I guess for this one it will be yes. And also because our application should be highly available, so we should ask, do we expect to have like a tunable consistency, or not that great consistency? Tunable consistency. And for this it will be yes. And basically from these 6 questions, I guess that we have a solid understanding on how our system should look like. And in today's video, we just talk about what's going on with you, Mero. Okay, Mero, I guess has a problem because it doesn't add the sticker for me. I don't know what's going on with the remote. I don't know. So basically that's it for this video, and in the next video we will talk about the cap theorem. And yeah, that's it for this video, and I hope you like my content. If you like my content, subscribe and hit the notification bell so you'll never miss a video, and see you guys in future problem.